Hello, and welcome to my Math Companion. In this video, we will look at another problem involving simultaneous equations. And this problem is a little tougher than the previous one. Let's begin. Jack and Bill are playing cards. Jack knows that 2 times his number of cards is equal to 2 less than 6 times Bill's number of cards. Given that Jack has more cards than Bill, and the difference in their number of cards is 43, how many cards do each of them have? So as you can see, this problem does involve quite a bit of information. But since this is a problem involving simultaneous equations, we must first establish our variables. The two things that we don't know is the number of cards that Jack and Bill have. So we'll assign variables to them as J equal to the number of cards with Jack and B is equal to the number of cards with Bill. Next, the question states that Jack knows that 2 times his number of cards is equal to 2 less than 6 times Bill's number of cards. So here it's a simple interpretation of wording. So 2 times his number of cards means 2 multiplied by his number of cards, which is J. So we would write that as 2 times J is equal to 2 less than 6 times Bill's number of cards. 6 times Bill's number of cards is 6b, and 2 less than something is that something minus 2, so that would be 6b minus 2. And the question states that these two values are equal. So 2j is equal to 6b minus 2. And that is our first equation. So after writing this equation, we see that we can easily isolate j here and write it in terms of b, since 6 and negative 2 are both multiples of 2. So if we want to isolate j, we will have to make its coefficient equal to 1. And since we see that 2 is being multiplied with j, we can divide by 2 on both sides of the equation. And we will get j is equal to 6b by 2 minus 2 by 2. So when you write 6b minus 2 whole divided by 2, you can take each term and divide it by 2 and subtract 1 from the other. So this leads us to j equal to 3b minus 1. And hence, we now know the value of j in terms of b, which is extremely helpful to us, especially in our second equation. So now this is our value of j in terms of b, and we see that the second equation is that the difference between the number of cards is 43. So we can write that as j minus b is 43 because the question does state that Jack has more cards than Bill, which means that if the resultant of their difference is a positive number, it must be j minus b and not b minus j. So now what we do is we substitute j for this value. So we substitute the value of j into equation 2, and we know that j is 3b minus 1. So we'll write 3b minus 1, and we keep this minus b, so 3b minus 1 minus b is equal to 43. And now this is a simple single variable equation where you have to solve for b. So now we get 2b minus 1 equal to 43, combining the like terms here. And now we do not want this constant term on the left hand side, so we must move it to the right hand side by adding 1 to both sides. And thus we'll get 2b equal to 43 plus 1, which is 44. And now since we want the coefficient of b to be 1, we can divide by 2 on both sides and get b equal to 22. So this means that Bill has 22 cards. However, the question also states that we need to find the number of cards with Jack. Note that we know the number of cards of Jack in terms of b, which means that we can substitute this value of b into this equation, j equal to 3b minus 1. So we can substitute this value all the way into this equation. So now we do that, and we see that j is equal to 3 times 22, where b is 22, minus 1. And this is equal to 66 minus 1, which is equal to 65. So this means that Bill has 22 cards and Jack has 65 cards. A good way to check your answers in simultaneous equations is to simply put back these values into the two equations that we formed. So what you would do is, you would put the value of j and b into this equation and check your answer, and you would do the same in the first equation. Put the value of j and b into this equation and check your answer, and you should get equivalent values on both sides.